All right, so a pretty involved problem here. Uh, you have initially MA moving in the x direction towards MB, which is at rest, and then it scatters off at an angle. After collision, it scatters off with speed VA prime at an angle theta prime, and MB scatters off with VB prime at an angle theta B prime. And so we're going to use three conservation equations here. First one is the conservation of momentum in the x direction. So this will be, initially you have MAVA, and that will equal MAVA prime cosine theta A prime, the x component of that velocity, plus MBVB prime cosine theta B prime. And so you have MBVB prime cosine theta B prime is equal to MA times VA minus VA prime cosine theta A prime, and that's equation 1. Second conservation law is conservation of momentum in the y direction. No momentum in the y direction. That is equal to MA VA prime sine theta A prime minus, this time, MB VB prime sine theta B prime, the vertical components, and minus because obviously they are moving, they are in opposite vertical directions. Therefore, the equation we get here is MB VB prime sine theta B prime is equal to MA VA prime sine theta A prime, and that's equation 2. And so the final conservation law is conservation of kinetic energy. So initially you have 1/2 MA VA squared. Finally, you have 1/2 MA VA prime squared plus 1/2 MB VB prime squared. And so what you get from here is that MA times VA squared minus VA prime squared is equal to MB VB prime squared. And we're going to multiply both sides by MB. So MAMB times VA squared minus VA prime squared is equal to MB squared VB prime squared. And that's our equation 3. Okay, so the first step in dealing with these is to square both sides of the equations or square both equations 1 and 2 and add them together. So what you get from there is the following. You get MA times MA squared times VB prime squared times sine squared theta B prime plus cosine squared theta B prime. So sine squared plus cosine squared of an angle is equal to 1. So this whole thing is 1. And that is equal to MAVA minus MAVA prime cosine theta A prime squared plus MAVA prime, MA squared, VA prime squared times sine squared theta A prime. Okay, so we can simplify both sides of that equation. What we get is MA VA squared minus 2MA squared times VA VA prime cosine theta A prime plus MA squared VA prime squared, bear with me, is equal to MAMB times VA squared minus VA prime squared. So the MAs drop out. This one MA term drops out from everything. One MA factor, I should say. And you make cosine theta A prime the subject. What you get is cosine theta A prime, the scattering angle, is 1/2 of VA over VA prime times 1 minus MB over MA plus VA prime over VA times 1/2 times 1 plus MB over MA. All right, that is our equation. And so to answer part A, to show that theta A prime can take certain values, we note, okay, for part A, we note that MA is less than MB. And so what we see here is that as VA prime equals VA, what you get is the cancellation. You get one. You have one half times 1 minus MB over MA plus 1 plus MB over MA. So MB over MA is cancel. You have 1/2 times 1. So cosine theta A prime equals 1 in that case. And so cosine of 1 is just 0. So theta A prime is 0 degrees in that case. And on the other extreme, consider the case where VA prime goes to 0. And so as it's going to 0, this term is dominating because the denominator gets smaller and smaller. So this term becomes less important. So when you just have this term and MA is less than MB, so MB over MA, that ratio is greater than 1. So this is a negative number. And so the smallest number cosine theta A can cosine can take is -1, right? So it will eventually approach negative. It will eventually get to -1 at that point, or the smallest value of cosine is -1. So at that point, the theta A prime will be 180 degrees. And so that is how the angles, the scattering angle, can vary between 0 and 180 degrees. And so in part B, we have that MA is greater than MB. In this case, the arguments here don't apply. Instead, what we can do is we can take the derivative with respect to VA of cosine theta A prime. And so setting that equal to 0 will give us the maximum of cosine theta A prime, right? And so the derivative is 1/2. I'm just going to write it down here. Is 1/2 minus VA over VA prime squared times 1 minus MB over MA plus 1 over VA times 1 plus MB over MA. And so that will be set to 0. And so that would give you minimum VA prime min of that is equal to VA times 1 minus MB over MA divided by 1 plus MB over MA to the power of half, or the square root of that. So plug into the cosine theta A prime equation, and you get and what you get is cosine. Well, this time we're going to call theta A prime phi. So you're going to get cosine squared phi is equal to 1 minus MB over MA quantity squared. And that's it.